There we go. I'm going for the last problems on lesson 6.4, beginning with number 12. Now this last set, before we hit number 17, use the same method, which I don't know if you've ever experienced. It's called the grouping method, and they explicitly tell you that in the homework. Solve this by grouping, because that's the fastest, simplest way to factor 4 terms. Get my paper out. Oh, 11 used this too, and I described it on the video from yesterday. So we'll continue on with 12. It says factor the polynomial by grouping, and so you don't have to figure out the factor pattern. You don't even have to find the greatest common factor first. You just have to see these 4 terms as in groups of 2. Because we're in the land of Oz, they're setting you up for success. In other classes, if you go past this, they might not have them in nice order like this, but everything's in order just for you. Okay? So you break apart the 4 terms into 2 sets. And this is all about greatest common factor, greatest common factor, greatest common factor. Check for any other factoring patterns. So we take the first 2 and see that their greatest common factor is x squared. Hopefully you're getting used to that idea. You know, you see how that's squared and that's to the 3rd. You pick the smallest exponent to find the greatest common factor. Now, on the right side, it appears there's nothing, but because they're both negative, -1 is a legitimate factor to factor out as a greatest common factor. Especially in grouping, you always want to find something, if possible, to factor out. And if I take a negative out of a negative x, I get a positive x. If I take a negative out of a negative 8, I get a positive 8. Now this is the part that makes people crazy, so pay close attention. Watch the magic. Watch the math, okay? I see these both have, this is just a number, x plus 8 is just a number, right? They both have that number in common. So there's another greatest common factor to pull out. So when you pull out a greatest common factor, you don't write 2 of them, you only write 1 of them. Then what I like to do is literally cross what I just took out as the greatest common factor and see what's left and write it. And that's the part people miss if they're not paying attention. Say, what just happened? In your homework, I think they write this one first and then the greatest common factor. The order doesn't matter. I like to write my greatest common factor first, and then I can see what's left over. Now here's the, always ask yourself, is there any more factoring to be done? If I see something squared, that is a potential of being factored. Since x is squared and this is 1 squared, I can use the difference of squares as my factoring pattern. So that's a yes. I have more. I thought I could move this thing. Sometimes I can move it up or whatever, maybe not. I don't know what I'm doing wrong. Oh well. Okay. If I touch the finger thing, and I should be able to move this around. And it's
2 fingers?
You're the hero. Thank you very much. That's funny because like when I was doing the recording, I couldn't get it to work, and then the next time it worked, but I didn't pay attention. I must have used 2 fingers. Thank you. I appreciate that help. All right, so in page 131 of your planner, we have this pattern. How does it break out? Take the square root of x squared. One factor has a subtraction sign. Square root of 1 is 1. And the other factor has an addition sign because we want negative x plus x to disappear. So when you multiply this, you get x squared minus 1. And I'm drawing on the thing. But now we're done. There are no more squared terms. There are no more factoring patterns. There, you will write 3 factors in your answer space for number 12. So that was the difference between number 11 and number 12 was you had to keep on factoring. So you have to be on alert, high alert, to see if there's more factoring to be done every single time. Number 13. And all of these are grouping. So we're just going to practice grouping. You just say, ooh, I could do that. And you'll say, yeah, you could do that. This is just giving you permission to understand all the ways groups of 4 terms can be factored. So now you're hopefully learning to recognize just from like that Kahoot. At the 12th question, we all should have been graph masters because you saw your mistakes from the question before. So here as we practice factoring, you'll notice factors sooner. You agree? See how 8's in both of these and x to the 3rd comes out? It's the smallest exponent. Belongs to the greatest common factor. Now here's another, what do I do when everything cancels? Remember there's always a 1. Okay, so if everything disappears, there's still a 1 as a factor. And this guy is a 27. And then x plus 1. And again, they're setting you up for success because they want you to be able to see these are common factors. Write it once. I pulled that out of this polynomial and write what's left. It's very methodical, very orderly. That looks like a perfect cube. I'll write it out. That's what my mind sees. I see a perfect cube here. So I can do sum of cubes pattern. That's funny. You see that? There must be a setting on here. It just shows 1 finger. That's where I got my cuckoo mistake. Okay, so here we go. Do you remember the sum of cubes? Page 131 is where you find the secret sauce. So it's the cube root, copy the sign, cube root, square it. You need a negative, multiply them, and square it. Don't forget this guy. He's along for the ride. And this guy, remember, after you do the sum of cubes, you're done. There is no more, no more. Done, done, done. because this pattern right here is the final. That's the final unpacking of two cubes that are being added together. Alrighty? Wait. Pause. Let me know. Hope you're enjoying the number game. That's what it is. You're good at finding cube roots, good at noticing patterns. Not rocket science. Okay. Number 14. Hopefully you are all keeping up with your homework after we get done together. So when you have a work day, you'll be ready to turn it in and be done with the thing. Okay, this guy has big numbers, but don't let him intimidate you. 125x to the fourth plus 500x to the third minus 8x minus 32. We are in the land of Oz, where 125 probably goes into 500. Pick the smaller exponent, and what's left? All right. Greatest common factor, greatest common factor. This guy has got a -8. When they're both negative, it's pretty like it screams at you. Take out a negative. That way you have a matching set of factors you can pull out as a greatest common factor. But they're not going to let you off the hook. We have some perfect cubes. Oopsie. Is that okay? Yep. You caught up to me? You need to pull it down a little. Put it down. There we go. It really does go fast. I mean, I have to stop, but the actual process, zip, zip, zip. I could,
zip, zip,
yeah.
Zip, zippity, zip, zip, zip.
That's math, isn't it?
No, not sometimes. Sometimes
Oh,
it's
man.
not as fast as that.
Sometimes it's snail pace. Okay,
Yeah.
That's okay. It's not about speed particularly, but somewhere along the line, somebody's going to demand you to get a job done quickly. It makes me, I don't like it, but it is what it is. Time is money, right? So that's why you kind of want to, kind of think about that anyway. I'm not going to pressure you into that, but real world calls. Okay, now I have to write this guy as a difference of cubes because he's a cube, there's a cube. Let's write a difference of cubes. 5x minus 2. Square it. Already got my minus. Multiply. Whoopsie, I just about forgot my squared. And then multiply. Squared the 2. Here we go. And bring this guy down. And you're finished. Finally, 125. I was looking for that as a perfect cube. Wait. You guys good with that greatest common factor that looks like a binomial? It's just an unknown number, remember? Rules are the same. You divide it out, write it once, then you write what's left over. Okay? Number, let's see, what do we got? 15. We have little numbers again. Practice, practice, practice. X cubed plus 3x squared. And you never know what you're going to get. Plus 6x plus 18. If you notice, I squiggle before the sign. The sign goes, you know, with the term after it. I see an x plus 3. And here's a tricky one. X squared plus 6 cannot be factored, so don't try it. How do I know? Because 6 is not a perfect square, and you do not have a sum of squares for a pattern. Practice, practice, practice. Building confidence, I hope. 16 and 17. Here we go. This is a good one. Because they're not both negative here at the end, but you still want to take a negative out. I see a 9 and an x cubed. I forgot to squiggle, sorry. A 9 and an x cubed leaves me an x minus 1. Well, I got an x plus 1 on my right side, but if I take out a negative 1, the x turns positive, like this, and the 1 turns negative. And I back to my common factor that I need. X minus 1, and then 9x cubed minus 1. Here's a tricky. Is 9 a perfect cube?
No.
Correct. So we are done. Thank you. Okay, I'll just give you a hint while you're writing down on number 17. There are 4 boxes. There'll be 1 in the first box, 1 in the second box, and 3 polynomials will end up in the last box. This guy is blank. And when you go to drag and drop, you'll see what they just want you to factor and fit them in the patterns. So one of them is a difference of 2 squares, one of them is a sum of 2 cubes, and the last one has no pattern at all. Thank you.